Hello class 7. In the previous class you have read about Pythagoras theorem and Pythagorean triplet. And today in this class you are going to understand the median and the centroid of a triangle. So take a look at this. Students, our topic is median and centroid of a triangle. First of all, we have to understand the term median. What is median? A median of a triangle is the line segment that joins a vertex to the midpoint of the opposite side. Here the words are the line segment, join, vertex, and the midpoint of the opposite side. Here you can see a triangle ABC, and D is the midpoint of BC, E is the midpoint of AC, and F is the midpoint of AB. And here the vertex A and the midpoint of BC joins together, and we can see a line segment AD. So a median of a triangle is the line segment that joins a vertex to the midpoint of the opposite side. So AD is the median. Likewise, E is the midpoint, B is the vertex, so BE is also a median. And here C is a vertex and F is the midpoint of opposite side AB, and so CF is also a median. So there are three medians of a triangle. Here in this triangle ABC, AD, BE and CF are the medians. So students, conclusively you can say that the median is a line segment that joins a vertex to the midpoint of the opposite side of a triangle. So here AD, BE and CF are the medians. Look these three medians carefully. All these medians meet at a point, intersect together at a point, that is G. You can also say that all the medians concurrent at G. So that point of concurrence is called centroid of the triangle. So for centroid we can say that the point of concurrence of the medians of a triangle, the point of concurrence of the medians of a triangle is called the centroid of a triangle. Here G is the centroid of the triangle ABC. In this triangle ABC, all these medians AD, BE and CF concurrent at G. So G is the centroid of this triangle. Now for special features we have to talk about for a special case. For an equilateral triangle, you can see in this equilateral triangle PQR, PM, QL and RN are the medians of this triangle PQR. All medians are equal. It means the PM, the QL and Rn, all these medians are equal. So PM equal to QL equals Rn. It means in an equilateral triangle all medians are equal. We can say that in an equilateral triangle all medians are equal. Now for an isosceles triangle, you can see here an isosceles triangle ABC in which AB equal to AC and D is the midpoint of BC, so AD is the median. E is the midpoint of AC, so BE is the median, and F is the midpoint of AB, so CF is the median. Okay, and you can see these two sides are equal. So the first thing about the isosceles triangle is medians to the equal sides are equal. You can see AB and AC are the equal sides, and hence BE and CF the medians are also equal. BE and CF are equal. And the last one AD. AD is also a median, but it is not equal to BE and CF. But here you can see that the AD is perpendicular to base BC. So the third median AD is perpendicular to BC, base BC. So median of to the base is perpendicular to the base. Now one more thing that is special. The centroid of a triangle divides each one of the medians in the ratio 2:1. Here you can see that G is the centroid of the triangle, and the statement says AG is to GD is 2:1. BG is to GE 2:1. CF is to CG is to GF is 2:1. It means all medians are intersected at a point which divides the medians into 2:1 ratio. So here AG is to GD, BG is to GE, and CG is to GF. All are equals to 2:1. Students, I think now you understand the medians and the centroid of a triangle and some special medians of special triangles. You can also watch me on my YouTube channel, Ocean of Maths. Thank you very much. Have a nice day.